Okay, we're going to be starting with scientific notation. So the first chapter is kind of a prep chapter, and it goes over a lot of mathematics and kind of technical stuff. And so we're going to be going over scientific notation, conversions, equations, a little trig. And so um, this is going to be a little weird for me because I won't be able to tell exactly where you guys are. I haven't met you guys yet. So bear with me. If this is kind of review, you can actually turn the speed up on YouTube and listen to it faster. Um, but hopefully it's not blowing you out of the water. So we're going to be doing scientific notation sometimes, and this occurs when you have numbers that are extremely large or small on your calculator. Sometimes you might see something like 4.50359 dot dot dot, and then you have this this little e, and then you have like a plus 15. Now when when we're writing it by hand, we would write 4.5 times 10 to the 15th power. And so we're basically taking 4.5 and timesing by 10 15 times, which actually means that we're moving the decimal to the right 15 times. So what I do normally is I take 4 and 5, and I've already moved the decimal over 1, so then I just keep adding 14 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So 4.5 times 10 to the 15th is actually thousands, millions, billions, 450 trillion. And so this will happen quite often, and we need to get used to actually seeing the numbers like this and being able to switch back and forth. Okay, so another example of a number, while this one is a big number, we gotta talk about small numbers. So you might see something along the lines of 4.503 e negative 22. So this is actually equal to 4.503 times 10 to the negative 22, which means you would divide by 10 22 times. Or in other words, you could say the decimal moves negatively to the left 22 times. And so to write this in a normal, just a normal decimal, it can be kind of tricky because what we have this one move here where we're not adding a zero. And so it's like 0.4503, and then we start adding more zeros. And so if I was to move the decimal over here, we would actually be moving the decimal 21 more times. And so I'm going to be adding 21 zeros to the front of this. Point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 4, 5, 0, 3. And so when you have to deal with these numbers often, you don't want to be writing all those zeros. It's a quicker way to write it. And I hope you can see the utility in that. So for example here, like a carbon atom, if you're looking at the radius, roughly the radius is 1.7 times 10 to the negative 10 meters. Okay, let me clean that up. So that means we would take 1.7, and I like to first move the decimal over 1, so it's 0.17, and then I have to add 9 more zeros to keep moving that decimal point over. So it would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 7 meters. So it's a little quicker to write. The Milky Way, on the other hand, is astronomically large. It is, bear with me, 1, I have to double check my notes here. 1, 2, 3, 4, 5, 6, 7. It's with 21 zeros after that. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 meters. And so we're going to go the other way. We don't want to write this with 21 zeros. So we imagine moving the decimal point here all the way up to after the first digit. And so that would come out to be 1 times 10 to the 21 meters, which is a lot more concise to write. By the way, another example, if I had something like 4,530,000, and I wanted to write that in scientific notation, I would move my decimal all the way up past the first leading number. So I would write this as 4.53, and then I would think this is 1, 2, 3, 4, 5, 6 over. So I would times it by 10 to the 6. Okay. Now we move on to significant figures.